Hey everyone, so today we're going to go over some more complex incline problems. Now for the first example, we have a block slides down a 40-degree incline after initially being at rest. What is the acceleration of the block and what is the final speed of the block after it travels 250 meters down the incline? So before we do anything, let's just draw this out to get a visual. So we have our block over here, and the only forces acting on it would be our normal force and then our force of gravity dragging it down, Fg, and then we have a 40-degree ramp. Now it's important to note there's no friction in this example. Now the first part is, what is the acceleration of the block? So let's write the net equation. The net force is equal to the force of gravity, since there's no friction. The net force is equal to mass times acceleration, which is equal to mg sine theta, since this is on a ramp. The masses will cancel, and then we have acceleration is equal to g sine theta. And then acceleration is equal to 9.81 meters per second squared, sine of 40. And acceleration, when you plug that into your calculator, will be equal to 6.3 meters per second squared. And then the second part of the question is asking what the final speed of the block is after it travels 250 meters down the incline. So let's just write everything we have. We have our initial speed being 0 meters per second. We have our final speed, which is what we want to know. We have our distance, which is equal to 250 meters. And then we have our acceleration, which we just found to be 6.3 meters per second squared. Now, is there any kinematics equation that we might use that has these four variables? There is, and that would be Vf squared is equal to Vi squared plus 2AD. The final velocity squared is equal to the initial velocity squared plus 2 times acceleration times distance. So we can keep it Vf squared is equal to 0, since the initial velocity is 0, plus 2, 6.3 meters per second squared, and 250 meters. And then when we square Vf, and we square the right side as well, Vf is going to be equal to 56.2 meters per second. And that's your final velocity. Now let's try one more problem like this, except this time we're going up instead of sliding down. So now, the next problem is a block travels up a 30-degree inclined plane with an initial speed of 15 meters per second. What is the acceleration of the block and how far up will it go? So for this problem, let's once again draw it, except this time we can draw it like this. We'll have a block on it. We have a normal force acting on it. It's going up the ramp at 15 meters per second. And then we have the force of gravity, which is almost pulling it in reverse or slowing it down. And then we'll have a 30-degree ramp. Now the question's asking what the acceleration of the block is and how far up it'll go. So once again, we can write a net force equation. F net is equal to negative Fg, because that's the only force, again, we have. But this time, since it's in the opposite direction of the way it's moving, it's going to be negative. And then mass times acceleration is equal to negative mg sine theta. Once again, nothing really new other than that negative sign. We cancel out the masses. We're left with acceleration is equal to negative g sine theta. And then we can plug our values in. Acceleration is equal to negative 9.81 meters per second squared. And then sine 30, which is equal to 1/2. And our acceleration is equal to negative 4.91 meters per second squared, which makes sense since it's going in the opposite direction of the way it's moving. And then now, once again, we'll write out our given to find the the distance. So we're left with our VI is equal to 15 meters per second. Our VF is obviously equal to 0 since it stops. Our acceleration, which we just found out, is equal to negative 4.91 meters per second squared. And then our distance is what we're looking for. So if you haven't noticed already, we can use the same equation we used in the previous example. VF squared is equal to VI squared plus 2AD. We'll just rearrange it a little bit. So to solve for D, we can just go VF squared minus VI squared divided by 2A is equal to D. We can plug our values in. We'll get 0 minus 15 squared is equal to 225 over 2 and negative 4.91 is equal to D. And then when we put that into our calculator, D is going to be equal to 22.9 meters. So as we can see from these two examples, as long as we find our net force equation and we plug the right values in, we can get our acceleration, and then using what we're given, we can pretty much solve for whatever they're asking for, as long as we use the right kinematic equation. Thank you.